All right, welcome to the CAN bus investigation terminal challenge. This one involves playing with the controller area network, um, essentially packets from a dump. And if you're unfamiliar with what the CAN bus is, the CAN bus is primarily used in automotive vehicles. So, your car is running one or more CAN buses, which is a sort of network that different nodes, electronic nodes that your car uses, that's essentially how they interconnect and communicate with each other. For example, the infotainment system talking to like the engine control unit, um, or the engine control unit actually, talking to the different components on the engine. But it's this bus that anyone attached to it. It's pretty simple. It's all electrical signals, voltage levels. Anybody can attach to it and read and write to it. And it allows actually some interesting attacks. And there's a lot of research you can read into on CAN bus. But yeah, it's the primary network on a vehicle. Now, typically, or some of the more modern vehicles will have like an Ethernet. They can have an Ethernet network in the car, but that is not nearly fast and robust enough for more that real-time control of a vehicle, and that's why CAN bus is used more for, think like triggering ABS or controlling the engine, things like that, where it's really needs to be fault tolerant and it's mission critical. Whereas some of the more infotainment type stuff, displays and things, sometimes those leverage Ethernet. But reason I know a little bit about this, back in 2019, about a year and a half ago, I gave a talk at B-Sides, Iowa, on introduction to car hacking with the CAN bus. And so if you're interested in understanding more about the CAN bus and how it all works, how the packets are constructed and how those work, and how you can do some reverse engineering even on your own car, I definitely recommend checking out this talk. There's also other great resources out there, which I do touch on at the end of this talk. But yeah, check it out. I'll put a link in the description. If you can't find it, just search this title here. It should pop up. But yeah, so getting back to this challenge, there's really two challenges within the Holiday Hack challenge that leverage CAN dump, and that's this terminal challenge, and then there's also an objective later on with this sleigh. But this one is pretty simple, kind of dip your feet, looking at different CAN packets in a dump. So kind of like if we were to run Wireshark and capture packets that our computer's getting and sending, except this was done on, I don't know what the context of this challenge is, but a car, for example. Anyway, so here it says in your home folder there's a CAN bus capture. Oh, from Santa Sleigh. Okay. Data's been cleaned up, so it's not too noisy. CAN bus, just reading from it, there's a lot going on the bus at once. So when you're capturing like from a car that's on and operating, it's a lot of data to look at. But anyway, it looks like they cleaned it up, so there's not too much to deal with. You'll see record of an engine idling up and down, and also in the data is a lock signal, an unlock signal, and then another lock signal. So our task for this challenge is to find the unlock, essentially packet, and then we have to submit the decimal portion of the timestamp of that unlock code as the answer. Okay, so if we just cat out this, actually, how long is this CAN dump? Okay, 1,000 lines. So we'll just cat this out here. Okay, so some important things, kind of trying to explain the format of this file. You've got your timestamp here. You've got the interface. So this was a virtual CAN interface that this was reading from. And then this is the actual contents of the packet. It's actually not that much data. And I'm going to open up a nice reference from Wikipedia, because I know there's a good picture on here that explains the packet. Let's see. Probably should have had this. Here we go. All right, so with this is a single CAN packet, also known as a frame. You've essentially got your arbitration ID, and the arbitration ID in a CAN network basically identifies what that packet is responsible for. So like an ECU, engine control unit, might have a certain arbitration ID for. I'm not a car person, but something with the engine. There might be an arbitration ID for controlling or the status of the windows. Are they rolling up or down? Arbitration ID for dealing with the speakers for the infotainment system. So it's an identifier for what that packet is responsible for. And typically these are actually when you're talking about cars, these are usually proprietary to the manufacturer, and that's why this is not a set and agreed upon standard that all car or vehicle manufacturers agree on. It's all arbitrary, defined by the individual manufacturers. It can even change from model to model, year to year on the same car. So the big thing with when you're looking at doing analysis of CAN, on a vehicle, there's a lot of like reverse engineering that you have to do. And some people have tried to open source some of their knowledge and share that information to better understand exactly what their car is doing. But anyway, you got arbitration ID, and then you've got later on in the packet got 8 bits of data, which is representing data that is associated with this packet, like what sort of action is this packet actually doing. Cyclic redundancy check at the end, and as you can see here, there are voltage levels. So the CAN high and CAN low, that's basically all it is. It's a two lines with voltage being sent across them. And when they when you're reading the voltage level, and the reason that there's actually 2 lines instead of 1, that's for fault tolerance. So if the voltage level on CAN high is not reflecting the mirror of CAN low, like you have a not a perfect mirror, then you know that there was something wrong, and you should probably disregard or be aware that that could be an erroneous, whether that's noise or something was malformed with that frame. So this is for redundancy, for fault tolerance purposes. It's the only reason there's actually 2 signals there. But anyway, as the voltage level drops and increases, that is basically that cliff or edge is indicates the flipping of a bit, so either 0 or 1, and it's all voltage levels. So that's how the CAN packets work, or CAN frames. So if we come back here, basically all we need to concern ourselves with is we've got this arbitration ID, and then we've got the data for this specific packet. So I'm seeing a lot of 244s, and I will say I'm a bit of an advantage here, having actually done analysis on real cars, and like you can see patterns. You can start to see patterns, and so I just know that obviously this challenge told us that there was an idling engine here. So typically, the tachometer is reading from a certain arbitration ID, or a certain frame, and then that data is basically where the level of the RPM should be. So I see here 244, and then I see all these different data values that are kind of bouncing up and down. And to me that indicates that that's probably the engine, because the arbitration ID is the same, and we're just having some minor differences in the data field. Okay, so now if we scroll through, we do see some slightly different arbitration IDs here that could be for something else. Now remember that the original challenge said there's a lock, unlock, and lock sequence, and we need to determine the timestamp of the lock, or excuse me, the unlock. So I will just use some grep here. What I'm going to do is -v. This basically excludes instead of matches against. So I'll type in 244 and then the pound symbol, and this is going to exclude any lines that matches, and so we'll get to see just the arbitration IDs that aren't 244. Okay, so now we get we got 188 and then a bunch of zeros all the way down, so that really doesn't tell us anything. And then the only other arbitration ID here is 19B, and it looks like we have all zeros, and then there's a F located in this data, and then there's all zeros again. So to me, this is going to be your lock probably. This is going to be your unlock, and then this is going to be your lock again. So for the purposes of solving this challenge, it said to get the decimal part of the timestamp, so we'll just copy that. And then we'll run to answer. There are 2 lock codes and 1 unlock code. What is the decimal portion of the unlock timestamp? And answer is correct. So that is how you solve that challenge for the CAN bus investigation terminal. We'll catch you in the next one.